Another physical property lab is going to come around the corner, and this one focuses on refractive index. Now, this is something that you probably have already seen in the lecture room so far, because I've probably brought in those neat little water marbles. So those very small glass beads that suck up all of that water, they grow 300 times their size, and they're mainly made up of water. So that way when we put them into a flask with water, they somewhat disappear and you can't really see them in there. So that was refractive index, or refractive index demonstration. So let's talk a little bit about the theory of refractive index before we talk about how to measure the refractive index. Okay, so what happens is that you have to imagine a surface. And here's the surface. Now this surface is going to be made of a prism. Now we've all seen prisms before, right? We can shoot light into a prism, and if we've got the right type of prism, the prism will divide the light up into all of the colors of Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. All right, well, we've seen refractive index at work. Refractive index is going to take basically a light sample, and the light sample can come from the bottom up into the prism, and on this prism, if we have some kind of liquid solution that I'm just going to kind of do a blob of it here. Yeah, you remember that old movie, The Blob? If you've not watched The Blob, I would highly advise you to watch The Blob, because those were horror movies back in the day, and then you can kind of laugh at it now compared to the movies that are coming out. But there's just a blob of liquid, and this liquid will take the light, and as the light passes through the liquid, the light will actually bend. You see the same thing at a swimming pool, right? You're in the swimming pool, your top half is above and your bottom half is below, and the two halves don't necessarily meet up. You see a distorted image. And that's because the light that's coming into the surface of the pool is getting bent by the water in the pool, and it offsets the bottom half of your body so that they don't perfectly line up. The same thing is happening with refractive index. What's going on is that we are shining a light into a sample, typically liquid, and that liquid is bending the light just like the pool water does, and we are measuring the angle that it bends. That is the purpose of the refractive index, and that's the purpose of the refractometer. That is what we call the instrument that measures, of course, the refractive index. Refractometer. Okay, so in a nutshell, basically, bottom line, that's what's going on with the instrument. Now, the good thing about this is that many of the liquid samples, they bend light a certain way. So this gives us somewhat of a fingerprint. The machine that you will be analyzing on will go to 4 decimal places. At this 4 decimal place location, you're going to have a very hard time finding samples that will bend light exactly the same way. Just because we can go out to those 4 decimal spots, we're going to see samples that will be really close, like a whole group maybe will be 1.4 something. And then the group gets smaller when we go to maybe 1.42. The group gets even smaller when we go to 1.423, and the group actually becomes even smaller than that when we go to that 4th decimal place that we can measure from. And honestly, there's very few things that will bend the angle of light the same exact way. So therefore, we call that a fingerprint. A very good indication, a very good intensive property that really doesn't change depending on the amount of substance, that is a property like melting point and boiling point is, that we can use to identify a substance based on a list that's provided. So this is going to be the first kind of half of the lab experiment that you're going to be doing. You're going to be using an Abe refractometer. Some people call it AB. If I call it AB, I'm typically going to call it baby refractometer, and I just don't like the way that that sounds. So I like the word Abe much better. So Abe refractometer is what we're going to be using. Now, there's a process of how to load a sample up on the Abe refractometer, and that process is shown to you through a couple of YouTube videos that we have in this laboratory module. So please watch those. It will take you through the process of loading a sample on the instrument and removing the sample and cleaning the instrument after you're done. One of the things that I want to talk about is the cleanup process. So in the cleanup process, in those videos, they're going to be using denatured ethanol. At least one of them does. We don't really use ethanol. There's a better solvent that we use, that we like to use at least in our lab, and that's acetone. So over near the Abe refractometers, you are going to see a squirt bottle of acetone. That is why that is there. We want you to use the acetone to clean the prisms with. That is why we use it. So that way the person that's behind you can go ahead and run their samples on a clean prism. We don't want to leave any kind of chemical on them at all. Next, something else that we want to talk about is the purpose of the chem wipe. Now, for some of you, you've maybe never used a chem wipe before. Think of these as eyeglass towels, right? So most of the time you spray some kind of special cleaner on the lenses of your glasses, and some of you will buy those really thin, non-abrasive wipes to wipe the front and the backs off. That's kind of like a chem wipe. We use chem wipes whenever we want to clean something that's very fragile as far as glassware is concerned, especially in the laboratory. So we're going to use the chem wipe. Do not use paper towels to clean this prism, because paper towels will cause scratches, and scratches are bad news for the refractometer, and it's bad news for you if we see you using paper towels to clean that refractometer. So stay away from them. Don't use them. Just pretend like they're not even there. Use chem wipes, which will be located beside the refractometer when you go over and you run your samples. Something else that we want to talk about according to the instrument itself is the way we load the sample up. In one video, you're going to see one person load the sample with the prism closed, and in the other one, you're going to see them open the prism up to add a couple of drops directly on the prism. Which one do we have? Because those are slight differences in the videos. If you've watched them, keep in mind, I'm like Santa Claus. I know if you've been good, I know if you've watched them or not, so you better watch them. So which one do we have? We're going to open the prism up and place our sample directly on it. So that's the video with the girl from the community college that's showing you how to load the sample up, not the one from the professor or the instructor showing you how to load that refractometer. So you load it directly on the prism and you shut it. All right, there's a couple of things to the eyepiece that they didn't really show you on the video that I need to go through and explain. First off, in the eyepiece, when you look through it, what you should be seeing is a dark area and a light area. And then there's going to be some crosshairs in the center. And the whole purpose of the refractometer, the way that you know that you've read it the right way, is that the dark area and the light area should be very clear cut. This should be a very distinct line. That's what I'm going to call it. A distinct line. It should not be fuzzy. If it's fuzzy, then you know that you have not set up the attachment or the machine the right way. That is a fine adjustment tool on the front that slides back and forth, and it sharpens the dividing line for you. So what you need to pay attention to is, number one, make sure that this line up at the top is not fuzzy. On the eyepiece in front of the instrument, so let's say that this is the front of the instrument, right? And you've got this dial here to the side, and you've got the prism, and then the lamp kind of comes around here, and then you've got the switch that cuts off and on. There is a dial up here at the top that will slide back and forth. This dial will take care of the fuzziness. So when you look through the eyepiece, and if this seems fuzzy to you, you take this dial in the front and you move it left and right until this image becomes sharper. So you'll see a dark area and you will see a light area. The purpose of the dividing line is to make sure that this line that gets created is right in the crosshair. That is where you want this thing, right there in the center. And once you dial it on the crosshair, you are ready to read your measurements. Now, what if it's not on the crosshair? What if maybe the dark and light areas may be there? So if I go up and kind of cover that in, this needs to be lowered, right? I need to make sure that this dividing line is right here in the center of the eyepiece. Well, that's the purpose of the side. This one will move your dividing line up and down. So you'll turn this up or you'll turn it down, and that will move this entire area up and down until you get that dividing line right there in the center. And once it's in the center, then you're ready to read your measurement. So the next step is to flip this button down like you saw in the video. The lamp will go off, and what you will see from that point through the eyepiece is this area turns into a scale. And there will be nothing but tick marks on the scale, and this will say like 1.4 something and 1.5 something, and wherever that crosshair is, that's the number that you want to read. So that's probably going to be the hardest thing that you're going to have to do, is learn how to read the scale properly. And we'll kind of work you through that in the lab. It's just like reading a ruler. That is what you're doing here. You're reading a ruler. When you report these refractive indexes, you're going to report to 4 significant figures. You really want to take advantage of the instrument, and that's the power and capability of the Abe refractometer. You want 4 decimal places at the end. Okay, with that said, that is the manual version of the refractometer. What will happen next is that after you run it manually, you'll then take our instrument and we have an automated one. Now the automated one does not print. It will have a digital readout. So you will put 1 or 2 drops on the automated refractometer and you will hit read, and it will tell you the reading of your sample. And you can compare that to your manual reading to figure out if they are the same. And that way you can feel pretty good about your manual refractive index. What do I do with the refractive index after that point? Well, we're going to give you a list. And the list will have possibilities. And you will determine what your compound is based on the refractive index in the chart. And that's all that this lab is. It's just like the melting point. It's just like the boiling point lab. There's no difference. We want you to read a sample. Once you have that sample, refractive index at least, the value for that sample, you're going to compare that to a list. You'll see that list in the lab right up in the laboratory module folder, and then you'll determine which one of these compounds is possibly the compound of the unknown. And that's really all that this lab is. So you'll have one unknown. You'll do a reading one time on the normal refractive index instrument. You'll do the reading one time on the automated instrument. You'll take that data. You'll look at a list, a lineup of possible compounds. You'll ID that compound, and then you call it a day. This lab is going to be very short and very sweet. That's all that there is to it. So that's the story with refractive index. And that's how we will end the lab. And really, that's kind of the onslaught of the physical property labs that you will see. In the upcoming lab, what we will do at that point is we will combine everything in together. So we will make you do a boiling point or melting point, we'll make you do a density measurement, we'll make you do a refractive index measurement, and you will pick out what compound it is from a massive table with many different physical properties that are located on it. So have fun, good luck, it's going to be short and sweet, and you're going to love me.